Here we've got over 5 pounds of pewter ingots. Bought these on eBay. I think this was about 60 bucks. Pewter is not cheap, but it's cheaper than some other metals. I melt these things down and make some cool stuff with them. So step one, I'm 3D printing the AirHarp case in polylactic acid, PLA, which is a material that's very easy to melt. It has a relatively low melting point of around 180 degrees centigrade. So I'm printing it with these sprue bases on it. One is to pour the metal in, and the other one is basically an air vent. Doesn't really matter which one you pour the metal into. And then when this is done, I'm going to stick it in plaster. The plaster is going to solidify and make a negative of the mold. And then I'm going to burn out the plastic, and I'm going to pour the metal in where the plastic used to be. So it's a process that has several steps, but it works extremely well. Hopefully it will result in a metal AirHarp case. Okay, the print finished. It took 1 hour 54 minutes, basically 2 hours. Looks like it came out okay. So I'm going to try to pry it off of that platform without breaking anything, and then we'll see if we can embed it in plaster. So it looks like it came out all right. This is just residue from the ABS mixed with acetone that I used to plate the bed. But you can see here on the underside of this overhang here, it's a little rough. And that's because FDM type printers like this WellSpot TAS 4 do not like to print stuff, fine details on under surfaces of things. They just don't. So I've been trying to clean it up with sandpaper, but it looks like it's still a bit rough. Probably what I'm going to do is paint it with some of that ABS goo and see if I can seal it, smooth it up that way, because once it's cast in metal, it's going to be very difficult, if not impossible, to fix. So I just painted the affected portions with ABS paste, and it did smooth it up a bit, so I'm going to go ahead and encase this in plaster. Now I'm mixing the plaster, 2 parts plaster powder, 1 part water, and I'm about to immerse the plastic part. Fudge, I need more plaster. Okay, let's try this again. Yeah, that's more like it. So I'm going to push it all the way in, and then I'm going to back it off a little bit so it's not actually touching the bottom, because we don't want it to touch the bottom. So right about there is about right. I guess I have to hold it there unless I can come up with a better way. I'm not going to film me holding it there for 20 minutes. Alright, the plaster is setting. Our model is embedded in it. Should set up in a few minutes, but it'll only be ready for casting in about 24 hours. So around this time tomorrow, we'll do the burnout, where we put this whole thing in the barbecue pit and let the PLA run out those 2 holes, and then we'll pour the metal. Hello, weasel face. So you need to stay away from the oven. So I've been cooking this in the oven. Back up, come on, back up, back up. I've been cooking this in the oven because it still felt a little bit moist. So it's been in there for hours now at the lowest setting, 200 degrees. I figured that would dry it out a bit and hopefully not crack it if you overheat this stuff. Oh yeah, I think that did succeed in drying it out. So yeah, you don't want to superheat something that's all moist, because it will explode the can. So now, hopefully, I've got enough moisture out, and it's been about 24 hours, and I've cooked it for hours in the oven. Hopefully, got all the moisture out, and I can cook it in the fire at maximum heat, which will burn out all this lovely plastic and leave me a nice orifice into which to pour the metal. So I went to do the burnout, and what do you know, it started raining. So not really my day, but I managed to liquefy the pewter that I put in there. I was going to put these in when it started to rain, so I will just Trying to keep the rain from going in this thing. I'm going to put off melting the pewter, and I'm going to instead do the burnout, which I should be able to accomplish in the rain. So we'll see how that goes. Okay, this is less than optimal, but whatever. I don't care. Rain or shine, I'm doing this thing. Alright, well, I'm going to let it cook for a while. Can this close all the way? Yeah. I'll let it cook. Close it with the lid open. Hopefully the rain won't inhibit the fire too much. I think it will be okay. I'm going to get it out of the rain, and then in a few hours, and take that sucker out. So here we are quite a few hours later, and this thing is still hot, and it looks like the coals are still smoldering in there. Let's see if it got burnt out. Oh yeah. This is actually a titanium spork. Titanium has a very high melting point, so shouldn't be any problems with that. That junk on the top is called dross. It's basically crap. I don't know. That's the scientific word for it, crap. We want to get that out of the mixture because it'll fuck everything up. So I'm going to use the spork here to just scoop the dross off and just flick it. Okay, the gunk has fully liquefied, so we're going to take that thin film of dross and we're just going to flick it. Try not to flick it on ourselves. And for the record, I am wearing safety goggles, and I would recommend that you do the same. There's a rumor floating around that liquid metal can be bad for your health. Alright. Here's our thing. This is still hot. Okay. Now, I'm going to take this and carefully pour it into there. Oh my god, it's heavy. Alright, here goes nothing. Oh shit, I just realized that maybe I shouldn't have done that. Let's see if I can pour some of this out without spilling on myself. That would suck. That's fucking hot, yo. Okay. This is fucking dumb what I'm doing. It's fucking dumb. Oh, okay. I'm just gonna call that good. I know that's gonna need to sit for a while. And how I'm gonna get that out of there, I don't know, but I can see plaster around here and then metal everywhere else. So, I don't know. Probably require some prying or something, but I'll figure it out. So, ow. So, this top piece pried off real easy. No trouble at all. Don't know if it would have been that easy if I'd made it a solid puck like I originally did. So I'm just going to kind of chip away. Oh, give me a break. I'm just going to kind of chip away at the plaster here. And you see the process. I'm not going to show the whole thing. And hopefully within minutes this thing will be free. So here's a method that works even better. So there's the last bit of plaster that is really persistent, does not want to come off. But I figured I've got it to the point where I can at least talk about it. So I think what happened is, if you see this line, it's kind of diagonal across here like that. But beneath that line, everything looks groovy. The metal is well joined, well annealed. It's solid. It has a sort of a silvery luster, which it should. So the bottom part looks like a good cast, but above this weird diagonal line, it's got this goldish tint to it, and it's got, if you look carefully, little holes and stuff, which it should not have, obviously. So I think, really guys? I think what happened is that when I was pouring the metal in and out, trying to get the level just right, I was trying to get the metal level to be as high as possible without filling the can, so that I wouldn't be able to remove it. That in and out pouring of the metal must have just fucked it up. I don't know what else to say. I mean, I think it probably eroded the plaster, caused like plaster inclusions. That's my best guess. I kind of had a feeling when I was doing it that that was bad. I shouldn't be doing that, but I didn't have an articulable reason not to. Well, now I know that you don't do that. When you pour the metal, you pour it, and that's it. You don't pour it back out again and pour it back in again and so forth. So, this was a good trial run. It's almost there. I can still test it for fit. See how the dimensions came out, and next time I pour it, I will just be smarter about how I pour it. But I'd say this is like 80% there, and I just need to get my process down a bit better. It does weigh a fucking ton. The whole idea of this particular AirHarp was that it's supposed to be light, so I don't know if I want to have a super heavy metal case on it. It kind of defeats the purpose, but you know, it's something to do.